Hello, good evening. Today is February 10th, 2022, and it's around 11:20 p.m. US time, US Dallas, Texas time. And I'm making this placeholder presentation to be given as one of the keynote addresses tomorrow, which is February 10th morning, US Dallas time, between 6:30 and I believe 8:30 a.m. in the morning, which will be from 6 to 8 p.m. In India, IIIT India, to celebrate International Women's Day. And so I'm very grateful to our host, Dr. Raju, for inviting me to give this keynote presentation. And I'll be up bright and early in the morning to give the presentation. However, if there is a technology, in case there's a technology glitch, I always make a recorded presentation and send the Zoom version to the host so that in case I'm not able to join, then they will be able to play this presentation. But I will be there in the morning and to give this keynote presentation and also answer your questions. Thank you very much. So I'm Bhavani from the University of Texas at Dallas. And let's see, I'm now going to share my screen. Right, so it's recording. I'm going to share my screen. Great. Okay, so the title of my talk, I'm sort of combining two talks. One is a technical piece, which will take hopefully about 40 minutes. And then the last 15 minutes, I will talk about why a career in cybersecurity/data science for a woman. Okay, so my talk is integrating cybersecurity and artificial intelligence. So again, the first part of my talk, integrating cybersecurity and artificial intelligence data science with applications in Internet of Things, in particular, Internet of Transportation and infrastructures. Okay, so my talk has three parts. The first part of my talk has three parts: integrating cybersecurity and artificial intelligence data science. Here, I will talk about big data security and privacy, privacy-aware quantified self, data science, machine learning for cybersecurity applications, and secure data science for machine learning, secure data science, machine learning, and AI techniques. How do you secure the machine learning techniques? Part 2 will be on integrating security and privacy for Internet of Transportation. It's a particular type of Internet of Things. And part 3 is applying security and AI, integrating security and AI for Internet of Transportation and infrastructures. A number of our sponsors I'd like to acknowledge, including Professors Alvaro Cardenas, my colleagues, Professors Murad Kantajalu, Professor Latifa Khan, our former PhD student, Dr. Raul Quinones, and our project coordinator, Ms. Rhonda Walls. Okay, the first part is integrating cybersecurity and AI machine learning data science. So I want to give some motivation. I believe I was the first to introduce this idea back in 1996, data mining, security, and privacy, at a keynote address. First, I gave it at the IFIP 11.3 in 1996 in Como, Italy, and later at the Pacific Asia Knowledge Discovery Conference in 1998 in Melbourne, Australia. And subsequently, I published I call it a landmark paper. I'll tell you why. When I was at NSF in 2002. So it's a landmark because when you're at NSF, you're a program director. And when you write anything in a paper that gets many citations. And as a result, because you are responsible for giving a lot of funding, right, to various researchers. So that's why I call it a landmark paper. But in any case, it did spawn a new area of research. That's called privacy-preserving data mining. Although the word privacy-preserving data mining was coined by researchers at IBM Almaden in San Jose in the USA. So you have the original data, you add some noise because you want to perturb the data so that the actual data is not known. The fact that you have, say, cancer is not known, but maybe you can sort of give some other sort of similar disease, sort of inflammation or something like that, okay? So you add some noise and then you modify the data mining process. And then the final modified result should be the same, because what's the point when you apply data mining when you give sort of incorrect results, right? So when I joined the University of Texas at Dallas with our PhD student, Dr. Murat Kantarjalu, my colleague, and I, she was Dr. Li Liu, our PhD student. We focused on privacy preserving decision trees and the perturbation method. And this was between 2005 to 2008. So, because at that time, there were a lot of privacy preserving algorithms. So data mining, security, and privacy is exacerbated with big data and data science, right? So we hosted an NSF workshop on big data, security, and privacy in September 2014 in Dallas. And we presented the results to an interagency working group, privacy, in February 2015. I'd like to say something interesting. So the person who funded this workshop for us is, guess who? Our first keynote speaker, Dr. Vijay Atluri. Okay, so it was good to give this keynote talk together with Dr. Vijay. Okay, so what did we do at the workshop? What did we find? Big data management, security, and privacy. Due to the technological advances and novel applications, we can now capture, process, analyze large amounts of data for security tasks. Such tasks also include user authentication, access control, anomaly detection, user monitoring, and protecting from inside a threat, right? So again, you need lots of data, right, that you have to gather about a person to give access, right? Analyzing integrated data collected on the web, you can identify connections and relationships among different individuals, and that could in turn help with homeland protection, disease outbreaks, and so on. This collected data, even if we anonymize it, if we remove the identifiers when linked with other data, it can re-identify the individuals, okay? So what happens when you put lots and lots of data together and put it together, it could re-identify the individuals. Security tasks such as authentication and access control may require detailed information about the users, right? So you could have multi-factor authentication and so on. So for example, for multi-factor authentication, you need like fingerprinting and various other facial recognition and so on. This information, if it's misused or stolen, it can lead to privacy breaches. And so what did we discuss at the workshop? We talked about different types of access control models for massive amounts of data, privacy enhanced techniques, right? Big data analytics for cybersecurity. How do you apply data science for cybersecurity? And what about secure machine learning, right? How do you secure the machine learning techniques? Okay, so we talked about privacy aware. So I'm not going to talk about access control models. I'm going to just touch upon all of the other areas. So privacy enhanced quantified self, because we are carrying the smartphones and this, that, and the other, our cell phones and laptops and whatnot. So lots of data being collected, right? And then there is this area called quantified, a movement called quantified self. And that's personal data collected by wearable devices, smartphones, apps, and so on. They are being analyzed to give guidance to users in improving their health or personal life habits. The data also being shared with other service providers like retailers using cloud-based services, bringing potential benefit to users. So essentially, lots of data being collected, which is good. Quantified self, the whole idea is to collect lots of stuff about you so that you can get advice, right? So this is a movement by psychologists and sociologists. So for instance, I opened the refrigerator and there is, I love vanilla ice cream and chocolate milk chocolates, but I don't keep any in my fridge, right? All the stuff I keep in my fridge are like fruits and vegetables and so on, all the boring stuff. Because so let's assume I have got vanilla ice cream, I will immediately be tempted to go and, drink it or eat it or drink it or whatever. And then wouldn't it be great if my cell phone or my refrigerator speaks to me and says, no, it's not good for you, right? So that would be really great. But imagine, and that's what the sociologists want to do. But imagine if you collect all this data, right? And somebody could collect and send all this to my insurance company, and they might think, okay, so she's eating a lot of chocolates, so maybe we have to charge her more, or she's smoking cigarettes, which is not good for her, and we have to charge more. By the way, I do not smoke cigarettes. So for example, data collected by device monitoring, like blood glucose levels, could be used by an insurance company to deny coverage, not only for me, but also for my son, as well as for my grandchildren, right? So such privacy violations could easily get out of control if data aggregators could aggregate financial health-related data with tweets, Facebook activity, all kinds of data collected. But there could be lawsuits, because there could be also psychological damage, right? If somebody posts that she is, she's smoking and she's drinking and she's an alcoholic, I mean, that's not good for me, right? So to address these challenges, we need tools to maintain privacy. So you can see the Fitbits and so on, and the glucose monitors, all the data being collected. So this is what we came up with: privacy-aware, policy-based, quantified self-data management framework. So you have health information, fitness data, location data, and so on. So we have data collection, data storage, data analytics, data sharing. Some of the data in the cloud storage offered as services, and this is what we designed: privacy-aware, quantified self-manager running on our mobile device. So what we are saying is, every step of the way, collecting data, storing data, analyzing data, sharing data, policies have to govern this data collection, data storage, data analysis process. So this is what we designed and developed, right? A mobile system, data management framework, cloud-based data storage. So lots of data being collected, and we can't store everything in our mobile device. Something has to be stored in the cloud. And based on the policy, some local apps running on the device will be granted access. Some of the data, some may be encrypted, will be stored in the cloud. Some cases you don't have to store, like say if you're 20 years old, you don't have to weigh a person every day, right? Because even if you put on 5 pounds when you are 20, it doesn't really, 5 pounds, what, 2 something kilos, it doesn't really matter so much. But if you are 70 years old, and if you put on this 5 pounds or 2 something kilos or whatever, then it's going to be it could be really bad, right? It could be taxing to the heart. So that's why you don't want to collect unnecessary data. In other cases, the data may have to be deleted. And if the data is deleted, then is it really deleted, right? So you need some audit checks to be carried out. We envision that data sharing and analytics will be carried out using services running in the cloud. Based on different scenarios, some of the data could be sent without any modifications, heart rate, and so on. Some others you may have to encrypt and modify. So this is what we designed and developed, just to give you a flavor. Our next topic is data science for cybersecurity. So you can ask, so what's the big deal, right? You use past data to build classification models. You predict the labels of future instances using the model, and it helps in the decision making. So lots of network traffic data. You have the firewall, right? You have lots of some attack traffic, and if it's attack traffic, you quarantine. You build the classification models to decide whether it's attacks or benign, and benign you store in the server. But this is a challenge. The models will have to be updated. Why? Because for big data, continuous flow of data, like stock market data, your network data, sensor data for IoT, continuous flow of data, very common in our connected digital world, massive amounts of data. So back like in the 20 years ago, we wanted to do this kind of work, but we didn't have really all the technologies at the time. But now there are various, due to advancements in data science, what we can do is come up with an ensemble of models, not just one model. So these models are changing because the concepts are changing, concept drift, concepts are changing. So today it says buy Apple, tomorrow buy what? Microsoft, then by Facebook, or now they call it Meta, or then by Amazon or Google, whatever. So these models are changing. So you may need human in the loop, but we have come up with the algorithm where these models are talking to each other and coming up with a classification, changing these classification models. This was jointly carried out with University of Illinois, Urbana-Champaign. So application architecture, evolver inside a thread. So what happens? The person is sort of typing all kinds of stuff. So you have you take the I chunks, right? So you have the streaming data. You can't have all of the data together. They are coming and they are continuously arriving. So you break the data into chunks. And for every chunk, you build a model. So you have an ensemble of chunks. So chunk I comes, extract features, right? And then apply learning. We have supervised learning, unsupervised learning, both types of algorithms, graph-based, unsupervised, supervised support vector machine. And then we build these models. And then we see, are these, and then once we build the models, you can't have infinite number of models. So are any of the old models outdated? If they are, then you throw away the models, right? So it's online learning. And then, right, so K+1 chunk arrives, and then you do the same, and that's a testing, and then is it anomaly or not, right? So that the research here is building this ensemble of models and throwing away the models that are outdated, okay? So that is applying data science or machine learning to cybersecurity. Now we want to apply what happens if securing these machine learning algorithms. What happens if these machine learning algorithms are attacked, right? So the adversary modifies data to defeat the learning algorithms, understanding. So this is the adversarial learning. Adversary is learning about what we are doing. We have to learn about the adversary. It's not concepts that are drifting. It's not online learning. It's adversary adapts to avoid being detected. It could happen during training time, that is data poisoning, during test time, modifying features when data mining is deployed. So there's a game that is playing between the data miner or the machine learning model and the adversary. So this is the boundary of the support vector machine. The red squares are bad instances. The blue circles are good instances. So see what's happening. Adversary is learning what we are doing and pushing the bad instances below the boundary line, so that now 1, 2, 3, 4, 5 bad instances are not going to be caught, right? So that's the whole idea. We have to find out what the adversary is up to and see how we can modify the algorithm. And that's what we show here. So the threat model example, we have test time, deployment time attacks. Attacker modifies X to X prime, modify packet length by adding dummy bytes, or add good word to spam email, add noise to an image. So what we have here, the red crosses are bad instances, the green circles are good instances. This is a support vector machine boundary, okay? And so these red crosses are not being caught because adversary is pushing that into the green circles. So the red crosses are not being caught because they are pretending to be good, right? So black dashed line is a standard support vector machine. What we are trying, and this shows really better. So this is a red crosses, bad, green circles are good. What we are trying to do is to move these these dotted lines or dashed lines into the blue line, which is the new support vector machine. So by moving this, all of these bad instances here will be caught, right? So you can ask the question, why don't we move this right here? Right, then we can catch all the bad guys. But if you do that, the green circles, the good guys, the good instances are also going to go as bad instances. So again, you don't want false positives, you don't want false negatives, but you want high accuracy. That's the goal of our learning algorithm. Okay, so that sort of gives you a flavor. Now I move on to our second topic, which is security and privacy for Internet of Transportation and infrastructures. Okay, so I think we are doing okay. So Internet of Things, transportation, you've got to your coffee maker or tea maker, talking to your television, to your Amazon purchases, to your cell phone and smartphones and televisions and clocks and whatnot, right? Everything is connected. That's Internet of Things. Similarly, or this could be Internet of Household, home things. This is Internet of Transportation things. So your cars are talking to your trains and to the trucks and to the roadworks and so on. So Internet of Things, major implications in the transportation industry. AVs, autonomous vehicles, aim at improving day-to-day activities such as delivering packages, improving traffic, and the transportation of goods. In the US, trucks alone carry an estimated 63.3% of the freight of goods. AVs are not limited to ground vehicles, but also aerial and sea vehicles with a wide range of applications. Level of automation for AVs are from 0 to 5, with current ground vehicles in the market have partial automation at level 2, and aerial vehicles. So aerial vehicles are drones and airplanes and so on, sea vehicles, submarines, and ground vehicles, cars, trucks, and trains. They have a higher automation of level 4. So companies have invested heavily. General Motors has got about 728 million they've spent in 2018, and actually they spent over $1 billion in 2019. I don't have the 2020 numbers, and of course we've got to get the 2021 numbers. Why? There's great potential in AVs and the improvements it can do to the transportation industry. Security and privacy concerns pose new challenges that need to be addressed as we move forward. Okay, so security of autonomous vehicles. AVs are using their environment, a variety of sensors, so camera, GPS, inertial measurements, LIDAR, radar, and so on. Previous research has shown sensors are susceptible to malicious tampering, IMUs are susceptible to sound waves, and GPS receptors are susceptible to spoofing signals, right? So vehicles should verify the veracity of sensor signals before acting, because remember, these are all sensors, tiny devices, they don't have lots of storage space and lots of processing power. So sensor-based, because AVs rely on sensors to evaluate and interact with their environment. Inherited issues, sensors are susceptible to GPS spoofing and transaction attacks that manipulate environment physical signals like sound and so on. Let's see, needed defenses, classical computing security like memory protection, cryptography, and so on. Authentication does not protect against these types of attacks. And no verification. Due to the real-time constraints, AVs trust and act upon sensor data without any form of verification. Okay, so these are some of the challenges. So what did we do? So we built a physics-based anomaly detector. So I'll tell you what. We use the physical properties of it's a cyber physical system, right? You have the gadget like autonomous vehicle is like, you know, all this mechanical stuff and some, and then you have to combine it with the cyber, right? So we look at the physical properties and model them. So PBAD, physics-based anomaly detection, that's our reference monitor, is the one that's going to look at all the intervene with all the security access. The algorithm consists of 3 parts: building a model offline of the AV's physical invariance, implementing an online tool to monitor expected and observed behavior to detect anomalies, right? And to raise an alarm if significant residual difference exists. Offline pre-processing, online verification, anomaly detection. You could ask the question, so what is the big deal? This is what we do all the time anyway, right? But the challenge is to build the model, right? So I'm a computer scientist. Dr. Cardenas is a top-notch control theory, control systems researcher, and a cybersecurity for cyber physical systems. So he developed the model. Right, so offline pre-processing, the AV's invariants are calculated using a well-known linear model for aerial and ground vehicles, accelerometer, gyrometer, magnetometer, and so on the X, Y, and Z axis or Z axis is used for the aerial vehicle. Vehicle positioning and steering angle is used for the ground vehicle. So this is the model that we built of the autonomous vehicle. K state, input sensor measurements, the Y tilde is pre-processing sensor reading, and so on. So X, Y, Z axis, as we said, moments of inertia, mass of mass vehicles, drag factor, and so on. So that's the offline building the model. Online, we didn't use any sophisticated machine learning algorithms. We used extended Kalman filter. We used it to predict AV's physical behavior and by estimating the unknown parameters by noise sensor input. So what did we do? The algorithm, we divided into 2 parts. One is the prediction and corrects the estimation before it's compared against the sensor data. And what do we mean by anomaly detection? The CUSUM is a statistical algorithm, is used to detect persistent attacks. An alarm is raised if the residual difference is larger than a predefined threshold, right? So that's sort of the challenge in the sense. Extended Kalman filter control engineers have been using for a long time, but we are not applying it to network traffic or financial data. We are applying it to sensor data and building a model of a complex system. Okay, so this is a physical implementation. We only tested for aerial and ground, not for sea, right? Because Dallas is what we had. Well, we have lakes, but anyway. So aerial, we had drones, aerial AV, Intel ready-to-fly drone, controller PX4 flight controller focused on detecting of GPS spoofing and gyroscope attacks. GPF attacks are detected after 0.2 seconds, while gyroscope attacks are detected after 1.5 seconds, right? And the overhead is about 5.4332. Ground AV, custom built on top of Traxxer Ford Fiesta, controller ROS kinetic cam, focused on detecting visual attacks on the camera. Attacks detected after 0.1 seconds. Overhead introduced is 2.251%. Okay, so you can see aerial and ground. Each threshold produces a probability of false alarms of about 2%. So although you might think it's only 2% overhead, I mean, false alarm is 2%, it's not acceptable. This day and age, right, back like 15 years ago, you know, when I said we had 20% of false alarms, and someone said that's totally unacceptable, you should be having about 5%. But these days, even 2% is not acceptable. You need to have like 0.0000002%, right? So we need to improve on these algorithms. And that's why I'm hoping that machine learning could help. So what's privacy? We haven't done much about privacy, but we've got some ideas which I am going to present. Beyond the security of individual vehicles, transportation sector could greatly benefit from a support infrastructure that allows communication between vehicles, motion sensors, lampposts, surveillance cameras to help identify traffic jams, reroute vehicles, and so on. From the user's perspective, privacy concerns arise from all the information needed by such system. Right? It's privacy because you know, when you go out, right, there's so many sensors. It can capture photographs whether you're smoking or some places that you are visiting that you're not supposed to visit. And it can send it to your insurance company. It can send that information to your relatives. It's not good. Privacy is violated. But what can you do? You need all this information in order to help the transportation industry, the AVs and the autonomous vehicles, land, sea, and so on, right? So you need to do analysis. You need to collect data, but this data could also violate privacy. So what do? So legislators, engineers, scientists should keep privacy concerns in mind as advanced IoT becomes prominent, right? This will aid in improving public perception and so on. So I'm going to talk later what we are doing in terms of privacy. Okay, so it's a short part 3, applications of SEC AI for Internet of Transportation and infrastructures. So data science AI. So first is, how can you apply data science for transportation? So this research we are sort of just beginning. Internet of Transportation subject to attacks. Streaming data is being collected from such systems, including autonomous and in future driverless vehicles. As transportation systems go electric, we need to conserve energy. Threats to security of such systems could cause massive damage, including accidents, loss of lives, and so on. Driving on stranded on lonely highways. Data science, ML, are being applied to analyze the data. Can stream analytics learning be applied to, say, financial data, and telecom data be applied to transportation data? So we have applied, remember, stream analytics to like network traffic data is what we applied. Can we apply those techniques to transportation, Internet of Transportation? Or do we need special kinds of techniques, right? So one of the main questions here is to understand the nature of the complex transportation data, adapt the stream analytics, and apply them to massive amounts of heterogeneous data. So this is the area of research that we are beginning. Another area, of course, is adversarial machine learning, right? So Internet of Transportation will, without a doubt, we will need machine learning, right? Because when you talk about autonomous vehicles, finding the best routes to travel from A to B, avoid congestion, avoid traffic, lots of things that machine learning can help, right, for autonomous vehicles. So optimum directions and all kinds of stuff. But the adversary is going to learn about the models that the vehicles are using and learn about the training models. And the adversary could be malicious, right, and thwart our learning process. And so the learning algorithms, vehicles algorithms have to adapt because we are using machine learning so much. And those machine learning techniques for the autonomous vehicles are going to be attacked. Eventually, it becomes game playing between the adversary and the vehicle's machine learning algorithms. Challenge, what sort of game will be played? Zero-sum game, Bayesian game. Need to understand the data. The need to understand the data is essential. And research on this topic is only beginning. Okay, that's adversarial machine learning for Internet of Transportation. Remember privacy for transportation. So what we are saying is, remember I showed an earlier picture where we collect all the stuff into our smartphone, and then we develop this data management, privacy aware quantified self data management framework based on policies. So we are saying we have this little gadget in the car. And so we get radar, GPS, camera, LIDAR, ultrasonic sensors. They're all coming in. And so some data could be encrypted in the cloud storage, some cloud-based services, and privacy-aware, policy-based autonomous vehicles. So what we are saying, and this is the future, data collection, data storage and access, data analytics, and data sharing. Everything has to be policy-based. So before you collect the data, what are the policies for data collection? Data storage and access, what are the policies? Data analytics, what are the policies? Data sharing, what are the policies? So policies have to drive this entire process. Okay, so what of this whole area emerging? Trustworthy machine learning, right? So one thing is, another thing like the adversarial machine learning, right? Machine learning techniques could be attacked. But what about trusting this machine learning, right? Instead of applying game theory and so on, another direction that is getting quite important and popular, a lot of researchers are working, because you're carrying out lots of computations, right? Organizations, automobile companies, third-party service, they're outsourcing a lot of their data. So when you use a third party for computation, data becomes available in untrusted environments. And when that happens, everything gets corrupt, right? You can have the man in the middle during data transmission, or inside a thread from adversaries, the third-party location where computation is performed. So data owners may need to protect the data that require cryptographic guarantees, right, about data security integrity. So there are a few areas for research where we are sort of exploring, like, remember Intel's trusted execution environment, Intel SGX platform. It's an execution environment, secure encrypted stream data processing for trustworthy analytics. So it has got secure enclaves where you can execute the code that is security critical, right? So Intel has provided this platform. So we have used it for a number of our projects. Need to explore the application also for all of this to Internet of Transportation. Because remember, some of the data, as I said here, it's sort of what happens that you offload it to the cloud storage and you access it through the cloud-based services, right? So we need to explore the applications to Internet of Transportation. And then other area is formal methods. Formal methods are being investigated for trustworthy analytics machine learning. That's an area that's really going to explode, right, in trustworthy machine learning. Fine. So summary and directions for the first part. Developments in AI, integrating cybersecurity, AI, it's exploding. Applications of AI for security, insider threat detection, and security for AI, adversarial machine learning. And privacy, we cannot forget. So we talked about privacy-aware quantified self. At the same time, Internet of Things, Internet of Transportation things, Internet of Financial things, Internet of Medical things, Internet of maybe even cooking things, who knows, sewing things. So we came up with, for Internet of Transportation, for anomaly detection, physics-based solutions. As driverless cars become a reality, more and more of the AVs will use machine learning. Therefore, how can we develop AI solutions for detecting malware in AV systems? And how can adversarial machine learning work in AV systems? Okay, I talked about that. How can we develop privacy-aware policy-based framework for Internet of Transportation and infrastructures? And what about trustworthy analytics and formal methods? Numerous opportunities for substantial research. So whatever I have talked about until now, I think we can have about 10 PhD theses. So I would love to see more and more students all over the world, including in India and in the USA, in Europe, Africa. You know, I also gave pro bono lectures at the University of Dushan in Cameroon, Africa. So I gave a 10-day lectures, 3+ hours a day for 10 days, November, December last year. And so I talked about trustworthy machine learning. How do you integrate cybersecurity and machine learning? And so I'm hoping that students from there, hopefully students from IIIT and also in our students in the USA, everywhere will focus on research in areas that I've discussed today. Numerous opportunities. Okay, now we are celebrating International Women's Day, right? Why a career in cybersecurity, I will say, and or data science for a woman? Okay, so I'm giving 10 reasons why a career in cybersecurity data science, right, for AI and AI for female, not just for women, also for underrepresented minority communities. And so one thing about underrepresented minority communities, every country, it's different, right? In the US, it's African American, Latino American, Native American, LGBTQ, Americans with disabilities. These are the underrepresented minority communities. But one group is common to the entire world, and that is female. So country by country, so India, there could be underrepresented minorities, Africa, and Africa, of course, several countries, right? There could be underrepresented minorities. So country by country, you've got to decide what to do. But female is something everywhere, it's common, right? There's men and women. Given the opportunity, women underrepresented communities can excel in any computing field. Cybersecurity, data science, AI, they're all exciting fields with so many innovations and developments happening so rapidly. And you can integrate it with many areas: arts, humanities, natural science, social science, engineering, business, medicine, law, IoT, whatever. There are many opportunities from research to academia to product development and startup. Then there are substantial funding. There's also substantial funding these days in India, I'm hearing. And millennial women, I'm a baby boomer woman, but millennial women and women and underrepresented communities and beyond, they have the flexibility and freedom to choose careers, right? So in my time, there were hardly any women or women of color or women of South Asian origin at that time. We're talking about when I was in grad school, right? It was like, what, 40 years ago? So hardly any women. So we had to sort of navigate and find our way. But now there are many women, quite a few women, I wouldn't say many, but we can have role models also from the underrepresented community. So in many areas, you can work from home from most days, making it ideal. But this was actually, so what I was saying was, if you're in computer science, you can work from home. But today with Zoom, using computer science, everybody's working, practically everybody is working from home because of COVID, right? Even doctors are working from home and giving telehealth and so on. So this becomes, before the pandemic, this was very, very relevant for computer science because we could work from anywhere. And doctors had to be in hospitals, lawyers had to be in courts and so on, but now everybody is working from home. Okay, so again, continuing, many cybersecurity, data science, AI jobs, they cannot be overtaken by robots, right? Robots. So because we have to develop these robots, we have to develop these technologies, we've got to secure these technologies. We need researchers and developers to collect, analyze massive amounts of data, like from the IoT systems or whatever. Cybersecurity, data science are highly paid fields for numerous job opportunities, right? Because they are highly paid fields. Why not the female and underrepresented communities take advantage? Female underrepresented communities can be financially independent with a career in cybersecurity, data science. And this is something, last part I'm really stressing for women. Financial independence means self-respect, less stress, and confidence. And I'm saying financial independence is a must for every person and especially for a woman. So why I'm saying that, because many women are in, bad situations, abusive marriages, and they are stuck there because they have no financial support, right? They don't have financial independence. So if you have financial independence, then you have a choice. I'm not saying just divorce your husbands and go away. Absolutely not. But if the situation becomes intolerable, you have a way out. Okay, so that's why I say financial independence is a must for every woman. Computing systems are everywhere from north to south, east to west. Therefore, these systems can be attacked. So you can make the world a better, safer place, with cybersecurity addressing the major problems such as violence against women and children with technology. Okay. So we need more women and underrepresented minorities in both cybersecurity and data science. Significant shortage. There are so many opportunities in cybersecurity and data science, okay? Yet so few women and members from the minority communities take advantage. Only around 10% in cybersecurity are women, and even far fewer from minority, like African Americans in the US, fewer. Percentage of women in data science is slightly better. I think it's more than 20%. right? And percentage of working in this highly lucrative field from minority communities is even less. So women and those from this and when I say minority, I feel I'm talking about minority in the US, right? As I said, African Americans, Latino Americans, and so on. And they're losing out on not just intellectually, but also financially. We urgently need mentors to motivate the members from these diverse communities and encourage them to get into these important fields. And we can do it if we all work together. We need the support of men from the majority group, majority race, right? So in the US, the majority race, of course, is Caucasian men. Okay, so my last chart, I believe, my advice to all women and underrepresented minority communities: do not be undermined by others. That is, when they say, often they say, oh, women are not good in STEM. Why are these women not doing, science, technology, and so on? Never give up. Even sometimes other women would put you down. So never give up. Work hard, set goals, be flexible, as life does not turn out the way we want it to, right? We have all these grand plans when we start, but then we get married, and women especially, right? They get married, they have children, they have grandchildren, right? So, so right now, I'm a grandmother, so I have small grandchildren. So I'm thinking, okay, how do I balance my full-time career with my job, with grandparenting? So there's books called Grandmothers at Work. And I thought, I was really excited to read that. When I started reading, then I got so unhappy because they are talking about grandmothers who are taking care of grandchildren when the children have to, either divorced or they're going to school and they have to, they work 40 hours, the grandmothers then go and spend another 20 hours with grandchildren. And it's really tough for them. They also give financial support. So it's not all easy. So women have to always be flexible. So what I'm saying is life doesn't work out, but you've got to be flexible. What I'm saying is flexible and adapt. Love your work, but also enjoy life. Be a role model to the younger women and your community and learn from successful women and members of your community, right? Even though you may get into administration, which is very important to support. It's very important to support women. Because women have to get into administration, because if you have, say, like 10 department heads and one of them has to become dean, if you have 9 men department heads and 1 woman, guess who the dean will be? Very likely it's the man. So if we can have 5 men and 5 women, then we can have a 50-50 chance for a woman to be selected, right? So, but you also have to keep yourself technical, and important to find mentors. So I want to add one more chart, how I succeeded. So I'm a Tamil from Sri Lankan origin. And so I lived in Sri Lanka for the first almost 20 years. And I did my undergraduate from University of Ceylon. Sri Lanka used to be called Ceylon. It's the south of India, right? And so it was not easy, again, being a Tamil. So I'm from a minority community. So we had to work extra hard. And so as I was finishing my undergraduate degree, I got married. My husband was finishing his PhD from University of Cambridge. And so I got married, went to England, University of Bristol, and I started my graduate studies. 5 years later, 1980, we moved to the US. So this was in 1975. I got married. 1980, I was 20. So 1980, moved to the US. And then I was offered a tenure track position at New Mexico Tech. My husband got a position at New Mexico Petroleum Center, but I turned down the position, tenure track assistant professor. My son was a baby, so I felt I couldn't handle all this, taking care of my son and having a tenure track. So I took visiting faculty. When you do that, your career gets derailed. So from a visiting faculty, I went to University of Minnesota for 2 years also as a visiting faculty in computer science and mathematics, and then I went to industry, Control Data Corporation, one of the top 3 computer companies at the time in 1983. And so I started being a senior developer. I love development. I was there for the first release of the CDC Net product. And then I wanted to do research. So I got a lucky break because I had to stay in Minneapolis because of my husband's job. So I became a US citizen in 1985, and Honeywell was writing for a big contract for secure database systems for the Air Force. And I interviewed at Honeywell. All 3 had to come together, me getting this US citizenship, Honeywell getting the contract, and Honeywell wanting to hire me. That's when I got into, in 1985 fall, cybersecurity and data science. At that time, it was computer security and data management. So then I worked for Honeywell for 3+ years. Then my husband moved to Massachusetts, so I followed. And so I was at MITA Corporation for 13 years, 3 years at NSF, so 16 on leave from MITA. And then I joined UT Dallas, and my career has really thrived. So what I'm saying is every time I had to make adjustments and adapt, right? And be flexible. So these are some things for women, because whatever said and done, women are sort of mainly the caregivers for the children. Of course, more men help these days. But so what I'm not saying, just forget about children, go and have your career, or forget about career and have your children. Try to balance both, and it is possible. I mean, you can't have the best of all the worlds, but you can be successful, to some extent, right? So now but then for the younger women now, and there are so many opportunities, right? So learn and be flexible, and everything will fall into place, and don't get disappointed. Never get disappointed. That's the main thing, because you've got to keep trying, right? I try and try and try. Sometimes some papers, some proposals, 5 or 6 times I try, 6th time it gets accepted. So that's my message. And I would like to thank my colleagues, right? And so I think I've talked for, I didn't sort of set the time, for just under 1, I think, but probably I started around 11:20. So I think we might have about 10 minutes for questions, and hopefully, right, I will be here in the morning, but just in case there's a technology glitch or whatever, hopefully they can play this. So I'm going to send the Zoom link to Dr. Raju. But again, I will be here tomorrow morning, my time, your time, Friday evening, between 6 and 8 p.m. I think Dr. Atluri goes first, and then I will follow Dr. Atluri. Thank you very much. So I'm going to, let's see, I'm going to, how do I get this? Sorry. Okay, it's still being recorded. What's going on? Oh, sorry, I didn't share the video, so it was that's okay. I forgot to share the video or turn the video on, so you wouldn't really be seeing my video, but at least for the end, there is this video. Anyway, thank you very much, and I will see you in the morning. Okay, thank you. Bye.